Okay, section 13 of the homework. Certainly we'll go through this. Just to give you an idea of the problem set. Certainly they should start out easy and maybe get a little more difficult over time. So 1, 2, we'll do each one separately. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 problems. Let me do another share with you. Okay, you see my whiteboard now. One problem at a time. There is an answer listed. It does say use the product rule. Before I do that, though, I want to point out, I don't think I would use the product rule in this one over here, but we will do that. If I were doing this problem over here, I would just simply multiply it out, and you would get 6x 5 plus 5x cubed, and then I would take its derivative. So I would simplify and then take the derivative. What do you get over there? 30x4 plus 15x squared. All right, do we get the same answer? Yes, we do. But let's use the product rule. All right, let's write this down. So f prime. Before that, I do that, I'm going to write down what the product is. F of x equals x cubed times 6x squared plus 5. So I'm going to just simply say x cubed. I'm going to take the derivative of that times the second function, which is 6x squared plus 5. We'll do the derivative later, plus x cubed times the derivative of the second function. And I'm using that hash thing or prime notation to tell you the derivative. What do you get over there? 3x squared. And then when you get over here, you get x cubed. And there you get, let's see, what do you get? You get 12x, right? Again, that's an answer. You could put that down and say, yeah, I did it. You did do it. Let's simplify it then. What do you get? Well, you get 18x4 plus 15x squared plus 12x4. Combine like terms together, what do you get? 30x4 plus 15x squared. All answers are the same, as expected. All right. Let's go to the next question. Problem number 2. And again, it says use the product rule. And certainly as I do this, I want to emphasize, maybe I should be a little careful about this one over here. I'm going to write down what the product is first. This equals, let's see, I'm going to just multiply it out, and it's going to be x squared plus 10x plus 25. That's the first function. The second function, I'm going to say it's E5, which is a constant, times e to the x. All right. So I'll make a big dot there. So f prime, I'm going to say the derivative of the first function. I realize some students says, well, I'm just going to write that down. I'm not going to put this prime notation down. And I would appreciate that. I don't want to put the prime notation down either. Times the second function, which is E5, e to the x, plus, whoops, the first function. And yes, I'll look at the answer key later, times the derivative of the second function. One at a time. Let's take a look at it. Well, the derivative of the first function, I'm just looking at the the work I've written down for me to do. That's 2x plus 10 times, well, I'm going to write down this as e to the x plus 5 now. Plus, let's see, x squared plus 10x plus 25. And the second function is going to be, well, e to the 5 times e to the x. Well, it's still going to be e to the x plus 5. All right, what am I going to do now? I'm going to factor it. E to the x plus 5 comes out. Time what's left over, 2x plus 10 plus x squared plus 10x plus 25. I'm going to simplify that now. I'm going to put the polynomial first. That's x squared. Let's see, 10x and 2x is 12x, right? And then 10 and 25 is 35. And now what do I left off with that e to the x plus 5? It's a fine looking answer. I'm looking at that and I'm wondering if the quadratic factor, well, I think it might be. You should do some simplification. I'm going to say 7 and 5. Now the question shoots up and asks, what's the better answer? Well, an answer that you can match up with the k. And so I'm going to look at the k and I see this answer here, x squared plus 12x plus 35 times e to the x plus 5, and it's this one over here. So it looks pretty good. I can match them up. Well, let's do this one over here. It does say use the product rule. But before I do that, I just want to multiply it out just to see if it becomes easier for me to do. And again, if you might find it difficult to multiply, but I don't. So 7, I'm going to use my cursive s to the minus 1/2. Let's see, that's going to be minus s. Well, minus 1/2 minus 1 is minus 3/2. Then I would get 14s. And then I would get minus 2. All right, that looks pretty simple. I'm going to write down h prime now. Pretty simple for me to do. No, I'm sorry, I made a mistake already. I'm not following their instruction, but I will follow their instruction. I just want to say the way I would do it is not the way they've asked me to do it. What do you get there? Minus 7/2. S to the minus 3/2. Let's see, plus 3/2. S to the minus 5/2. And then what do you get? Plus 14. Well, that's the answer I would list. You notice my plus 14 doesn't look good. I'm going to just erase it, put it down again. I'm going to check the k. I see the 14, 3/2 minus 5/2 minus 7/2. Yep, got it all done. Let me do the product rule though. All right. And again, I wouldn't use the product rule, but they did ask me to do that. So I guess I should do that. So first function, you notice I'm using a cursive s. I want to tell you why. If I wrote this s down, it looks like the number 5 to me. All right, that's why I'm not using that. I'm using a cursive s. If your penmanship's better, don't worry about it. So s minus 1/2 plus 2s. I'll take the derivative of that times the second function. Plus, and I'll go through each step. So s to the minus 1/2 plus 2s times the derivative of the second function, which is 7 minus s to the minus 1 prime. Let's go through the work. And let's take a look at this. This will be minus 1/2 s to the minus 3/2 plus 2 times 7 minus s to the minus 1 plus, we'll get the same answer, I assure you of that. And if we don't, we're doing something wrong. And what's that second guy's derivative? It would be, let's see, s to the minus 2, right? Well, I got to do some multiplications, and it's a little bit annoying, but I got to do it. So it's minus 7/2 s to the minus 3/2 plus 14. Let's see, plus 1/2 s to the minus 5/2 minus 2 s minus 1. Wow, it's a lot of work, isn't it? What do you get over here? Plus s to the minus 5/2 plus 2s minus 1. More work. All right. And I'm going to circle things, not circle, but maybe underline. I'm going to do the minus 3/2. Well, that's the only one I got there. I'll write it down for you. So it's minus 7/2 s to the minus 3/2. Let's go next on my list, which are these guys over here. And that would give you what? That would give you 3/2, right? I'll write that down for you. Plus 3/2 s to the minus 5/2. And I'll look at these two guys over here. And that's nice. They just disappear. Then what do you get? Plus 14. Mistakes happen all the time. That's why we need to practice to prevent mistakes from occurring in the first place. And let's see if we got what they said we're going to get. which is minus 7 halves, that's the minus 3 halves, 3 halves, that's minus 5. Wow, same answer. All right, what was easier? Simplification and then taking a derivative. If I just take a derivative and then simplify, it's more work for me. All right, your mileage may vary, and you do that by working towards the answers. All right, so what do you got over here? I'm going to look at it. I'm going to take its derivative, quotient rule. Long fraction bar, square the bottom, bring the bottom to the top. Derivative top is going to be 4. Whoops, made a mistake already. Minus the top times the derivative of the bottom, which is 2. All right, now suppose I'm done. Not really. Whoops, I had to square the bottom, didn't I? I'm going to square the bottom. What do you get on top? You get 8x minus 8x, no x's, minus 8. All right, I'm going to say it's a fine answer, but I want to point out that I'm starting to think that maybe it can be simplified a little tiny bit. And I'm going to put this down for you. So it's minus 8. On the bottom, I could factor a 2 out, and that would be squared. So it'd be 4x minus 1 squared. Yeah, you need to know algebra. And what does this give us? Lo and behold, minus 2x minus 1 squared. That's what we're looking at over here. All right. So that one's done. Let's do the quotient rule number 5 now. All right, let's put it down. Fairly simple. Long fraction bar goes down. Square the bottom. That's x squared plus 3x plus 1. Bottom comes to the top. That's going to be x squared plus 3x plus 1 times the derivative of the top, which is 1, minus the top, which is x plus 7, times the derivative of the bottom, which is 2x plus 3. Congratulations, you got the derivative. I keep doing that too. I'm sorry. It's squared in the bottom. I'm going to simplify. And so I'm too tired. I can't do it. You really have to start. I think building your strength up by doing things, and you'll get stronger over time if you start doing. The bottom is x squared plus 3x plus 1 squared. We'll look at the key later. I'm going to put a little side work down. So the top is x squared plus 3x. Let's see, plus 1, right? And I'm going to say it's minus. Let's see what we get over there. We get 2x squared. And you'd get 3x and 14x, which would be 17x. And 7 times 3 is 21. Well, when we combine terms together, I'd get minus x squared. 3x minus 17x is minus 14x. And then 1 minus 21 would be minus 20. I don't like all those minus signs, so I'm going to factor it out. And then I'll write down my final answer, which is x squared plus 14x plus 20. We'll check the key later. X squared plus 3x plus 1 squared. Put a box in that indicating finality. Let's look at the answer, see if we got it. And wow, we got that one right too. We're on a roll. Let's go to number 6. And number 6, whoa. I think I can do it. All right. I'm going to write down in steps though. All right. So f of x, taking its derivative. I'll kind of write this down in steps here for you. Again, when I say this, over time you will get faster. All right. So 1 plus e, 4 plus x, that's the bottom squared. Take the bottom to the top, times over the top, which is 0, minus, 12 times the derivative of the bottom. I want to point out that the derivative is pretty easy. Basically, the derivative of 1 is 0, and each of the 4 plus x, whoops, I made a mistake there. Back up. 4 plus x is really e to the 4 times e to the x, and its derivative is really easy too. It's e to the 4 plus x. Eraser out. And I'm going to do it. Yeah, I really mean that. I'm going to do it. So what do you get over here? let's see, did I do that right? Oh, I'm sorry. I think I did it. Yeah, I did it right. So what are you going to get? You're going to get, let's see what you're going to get. You're going to get minus 12 e to the 4 plus x over, whoa, this is going to be tough. 1 plus e to the 4 plus x squared. I got to be honest with you, multiplying this out probably has no benefit whatsoever to me. So I can put a box on it, and I'm hoping I've seen that in the answer key. If not, I'll have to, manipulate this a little more. Let's take a look. I'm seeing the final answer, minus 12 e to the 4 plus x over 1 plus e to the 4 plus x quantity squared. Looking good. All right, number 7 says calculate the derivative. Well, they're not telling me how to do it, so I'm gonna entertain myself with doing it the way I want to do it, which is simplifying it. What does this turn out to be? X squared. I'm just simplifying, by the way, 8x plus 5x minus 2. And I can take it very quickly, by the way. 2x plus 8 minus 10x to the minus 3. Put a box in that, indicate that's my answer. But then I see their answer, and I see their answer is different than mine. So I'm going to write this down for you. I want to see if I can match it. This is 2x plus 8. I notice they're not using any negative powers. It's going to be x to the 3 in the bottom. And I guess they get a common denominator of x cubed. And what do you get? 2x4 plus 8x cubed minus 10. And let's see if that's their answer. I'm looking at this. And I'm looking at this. Good. I actually prefer my answer better. All right. Again, your goal is to match the answer in the K. All right. Let's go to number 8. And number 8, what they want to do, calculate the indicated derivative. And this is dz dx, and they want to evaluate it minus 2. Well, the first thing I got to do is got to find dz dx. And dz dx, in this case, is z prime. And is that easy for me to do? I think so. Let me write it down for you. Again, I'm getting a little better at this. I really mean that. So z prime. Someone says, why do you get better by doing? You're going to get better by doing too. Chances are you're not going to get worse over time by doing things. Derivative of the top is 1. And then what I do, minus the top, that's x, times derivative of the bottom, which is 4x. I want to simplify that though, because it looks like it might be easy to simplify. And what do you get there? Well, you get 2x squared minus 4x squared, which is minus 2x squared, and you get a 1. All right, so I got my derivative. Now, someone says, oh, I'm done now. Well, we'll read the question. I don't think you're done, but you did find z prime. But what they want me to do is evaluate this dz dx. I'll write this down for you. They want me to evaluate dz dx when x is equal to minus 2. That's the same thing as writing down z prime evaluated at minus 2. Well, I think I can do that just by plugging it in. And let's put that down. It's going to be 1 minus, we're plugging it into the derivative, by the way. It's going to be 1 minus, well, when I square it, minus 2, it's 4. So 1 minus 8. And then bottom, you're going to get, let's see, 4, 8, 9 squared. I put this down. It's going to give you minus 7 over 81. Right? That doesn't look like a minus 7, does it? Let me get my eraser out. And I'll write it down again. And you should do this when you're on exams too. You want to write things down so people can read it. I did it again. Minus 7 over 81. Who knows? Maybe I made a mistake. No, it's right there. We're doing okay. All right, let's go to number 9. And number 9 says calculate the derivative. Again, the way you do it, the way I do it might be different, but I want to claim to you, maybe simplification might pay off. The stuff that you learned in Math 100. And I do want to simplify it. So I'm going to write f of x down in a simpler form for me. And that's going to be x squared divided by the root of x. Root of x is x to the 1/2. So what do you get? You get x to the 3/2. If you're struggling with basic things, like you're struggling with Math 100, you may not have learned Math 100 well enough. Sorry about that. You may not have learned Math 100 well enough to actually be successful in higher level courses. Right? And that happens. So I always say it's the what I call, they push you forward hoping you're going to get it next class or next class. It never works. You got to get this material as we teach it. So math 100, math 119, math 120. Of course, you're in math 121. What's next thing going to be? Plus 3. Your skills improve, though. I'm not saying that you have a 100% chance of getting everything in math 100, but when you take math 119, your skills in math 100 should improve, by the way, and so forth and so on as you move up. Later on, though, you're going to forget a lot of math, though. There's going to be a lot of stuff taught to you that is going to be forgotten. There's no doubt about it. This is going to be 3x to the 1/2 and plus 9x to the minus 1/2. Now, what happens to a lot of students, after they do a little bit of work, they think that's the answer. That's not even their question. Their question is calculate the derivative. And I think I can do that. And what do you get? 3 halves x to the minus 1/2 plus, I'm sorry, I made a mistake right from the get-go. If I took 1 from 3 halves, it's going to be 1/2. I'm sorry. Plus 3 halves x to the minus 1/2 minus 9 halves x to the minus 3 halves. Well, I like it. It's a good answer. I got to be honest with you, though. I want to just do a little bit of the factoring in the problem. So I'm going to factor a 3 halves out. And I'm going to factor out the worst looking power, which is x to the minus 3 halves. And again, we're just trying to improve our algebra skills. So what do you get over there? Gee, it's going to be x to a power, right? So that's going to be x. Well, that would have to be x squared. And that's 4 halves. Well, 4 halves minus 3 halves is 1/2. Well, next guy is going to be plus. Well, that would have to be x to the first power. And why is that? That's 2 halves. Well, 2 halves minus 3 halves is minus 1/2. And then when we get in the last but not least, I get minus 3. And that's a good looking answer. If you want to write it differently, again, you can. Let me write that down for you. You can write it as 3. Let's see, does x squared plus x minus 3 factor? Yeah, let's give it a try. X. Nah, not nice numbers. So I'm not going to do that, right? I tried, but not nice numbers. Let me get my eraser out. So 3 x squared plus x minus 3. And in bottom, you get 2 to the x to the 3 halves, which would be x root x. And that's a fine answer. Again, so when are you going to stop? Well, you can keep going and going and going. I guess I could multiply top and bottom by the root of x. What would I get there? 3 x squared plus x minus 3 root x. And in bottom, what do you get? 2x times x would be x squared. That's also a fine looking answer. Now someone says, what answer do you want? I got so many boxes, I'm confused. Let's look at their key and see what they give me. And you really want to start practicing it. And I'm looking at this thing over here, and I'm wondering which one they did. Well, I'm seeing it. And I feel good. I got it. All right. Again, you may want to practice, do more and more work. You get more and more fluid with this. All right. Number 10. Wow, that's a weird looking thing. And I realize for some students, they look at this and say, what the hell are you going to do over here? Well, what do I know about these numbers? I may not know what they are like exactly, but I do know what's a constant. So this looks really simple. And what am I going to get? I'm going to get 0. Check the key. And that's exactly what you're getting. Let's go next page. So far, I'm glad for problems like that. And this is calculate the derivative. Again, I'm of the opinion that you should simplify this. And if I were to do that, I'll write this down for you. When I'm simplifying it, I would get x cubed. I'm associating these two here. X cubed plus 6x times x plus 6. I'm going to multiply that out. You would get x4 plus 6x squared plus 6x cubed plus 36x. Again, a lot of people box that thinking that's what we're supposed to do. No, you weren't even asked to do that. I did that to make my life easier. So I'm going to write down f prime of x now. and I'll go in order. I'm going to do the highest degree variable first, which is 4x cubed. I just took this guy's derivative. Then I'll do this one. This is going to be plus 18x squared. Then I'll do this one. That's 12x. And last but not least, I got the 36. That's a fine answer. And I'm going to factor a tiny little bit. Not that you have to, but I'm looking at it and a 2 comes out clearly. 2x cubed. These are things you did in Math 119 to help you with the factoring of the problem. So that would be 9x squared plus 6x plus 18. Again, if you're using a rational root theorem to factor it down, it'd be a little bit easier to use a rational root on it. Let's see what answer they've given me. They gave me this one over here. Let's see if I got it right. I'm just checking. I did good. All right, let's do number 12. Number 12 is a derivative, and it says that a is some fixed number. What's varying is x, so it's going to be pretty easy to do. And what do you get? Square the bottom. Bring the bottom to the top. Times the derivative of the top. Well, the derivative of the top is just simply a minus the top times the derivative of the bottom. What's your bottom? 5x4. If you think you're done, you put a box on it. I would like to do a little bit of work. And I'm looking at the top and I'm wondering, can I do that work? And it is work. I know that. I just want to do a little side work. I just did it again. I want to do a little side work, and I'm going to say it looks like, this is side work, by the way. It's a x5 minus a squared, right? And then what do I get? I get minus 5a x5 plus 30 x4. I think I'm ready to write that down now. And what do you get at bottom? x5 minus a squared. And on top, what would you get? Well, it looks like you get minus 4. Right, I'll write that down. Minus 4 a x5. And then I get minus a squared. And then I get 30x4. A box in that. And certainly he's basically okay, struggle a little bit more with that. I don't know if it's necessary. Let's look at the key. I got the bottom right. Did I get the top right? Well, a different order, but it's 30x4 minus 4a x. Yeah, looks good. 5 and minus a squared. We did a good job. All right, let's do number 13. Number 13 says use the following function values to find the derivative of f times g and f divided by g at x equals 4. Let's write this down. So we're going to write down f times g, its derivative. All right, it might be hard, but let's put it, and not really, it's product rule, isn't it? So it's going to be f times g prime plus f prime times g. Well, I'm going to write down fg prime evaluated at 4. So it's going to be f of 4 times g prime at 4 plus f prime at 4 times g of 4. All right, let's see if we put the numbers in now. So what do you get? What's f of 4? And again, I'm not memorizing, I'm reading. What's f of 4? It's 4. And we'll check it in the key later. What's g prime of 4? It's minus 2. Plus, what's f prime of 4? It's minus 9. What's g of 4? It's 7. Well, this is minus 8, and that's going to be minus 63. What does that give you? Minus 71. Do mistakes happen? All the time. This is why we want to provide a key for you. So when you look at that, you could feel comfortable about it. Now let's do the other one, which was the quotient. And let's write that down for you. So f divided by g prime, fairly simple to write down. it's going to be G prime, G times F prime minus F times G prime. What am I going to do? F over G prime evaluated at 4. As soon as I can't even remember that, they're saying do it at 4. So let's write this down, and then we'll look at the values later. I'm not memorizing anything. G of 4, I'm sorry, I made a mistake in the notation. I just noticed that. And I've done that several times today already. So let me get my eraser out, and I just noticed that it's right over here. That's a 2, and I apologize for that. I'll do that, and it's going to be G of 4 times F prime of 4 minus F of 4 times G prime of 4. And certainly, I know I said a lot to you. Mistakes are going to happen. They're going to pile up too. All right. And what's G of 4? It's 7. What's 7 squared? I'm doing the bottom, by the way. It's 49. All right. What's G of 4? It's 7. I'm just looking at my notes, by the way. What's F prime of 4? It's minus 9. Minus, well, what's F of 4? It's 4. And what's G prime of 4? It's minus 2. 49 in the bottom, minus 63, minus 8. Did I do that right? Nope, plus 8. I'm glad I looked. What do you get there? 49, 55, minus 55, sorry. Let's look at our answer key, see if we got it. If we didn't get it, just have to look at it again, say I got it wrong. We got this, and we got this. Looking good. Now let's go to page 7. I think I'm done with that page. And I think we're getting, ooh, look at this one, use the product rule. Well, I'm going to use product rule then. And what's that going to be? It's an interesting problem, but let's put this over here. It's going to be the derivative of the function that follows with respect to x. And I can write it as a product. So it's e to the x times e to the x. And what do you get over there? Well, first function times the second function plus root of the first function times the second function. Well, that was easy. So it's e to the 2x plus e to the 2x, which is, whoops, I'm really screwing up today, which is 2e to the 2x. We did good. All right, let's do the next one. There's a little words to this one over. I really kind of wonder about it. They want me to find, certainly want to find the derivative, and then they want to say when is the derivative greater than 0, when is it less than 0. And so for me to do that, I got to find the derivative. All right, so let me put this down over here. So f of x is equal to x squared plus 2, and the top is x. So I have to find that first derivative. Square the bottom, bring the bottom to the top, multiply by the top's derivative, which is 1, minus the top, times the derivative of the bottom, which is 2x. I'd like to simplify that if I can. And I want to point out, we tend to give very manageable problems. What do you get over there? Well, you get 2, and it would be x squared minus 2x squared, which is minus x squared. All right. Now, I want to claim, if you don't remember what they said, I think it might be a good idea to read it. I really do. They want to know when the derivatives are positive, when it's negative. And this is going to be something you're going to be doing a lot of, but let's just simply write this down. This is the derivative, and they want to know when is the derivative greater than 0, and when is the derivative less than 0. These are two things they want to know. So this goes back to Math 119. And in Math 119, you did something called Sine Analysis. Let's put that down for you. We would look for the zeros on top, and that's going to occur at plus or minus root of 2. We would also look for the zeros on the bottom. What's nice about the bottom? The bottom is never 0. It has no real solutions to it. What are you going to do now? Test points. A good test point here would be 0. What's a good number after 2 that you could use? Maybe 2. And below minus 2, I'd say minus 2. You're going to plug it in and determine signs. If you plug in 0, what do you get? Positive on top, positive on bottom, it's positive. If you plug in 2 on top, what do you get? Negative, the bottom is always positive. If you plug in -2 into that first derivative, what do you get? Well, negative on top, but it's always positive on bottom, so it's negative. So I can write my answers down. When is this thing positive? Only between -2 and 2. I'll put that down for you. So it's positive. We're talking about this guy over here. When x is between -√2 and √2. When is it negative? From -infinity up to -√2. I'm going to put this in intervals, by the way. And the other place would be from √2 out to infinity. All right, let's look at our key, see how we did. And I noticed that they wrote intervals for both of them. And let's take a look. So again, when I mean take a look, I mean really take a look. Just say, oh yeah, I see numbers there and I got to be right. I would never say I'm right. It says that the derivative will be positive when x is between -√2 and 2. Well, I said that. And it said it would be negative on the interval between -infinity and -√2 and √2 to infinity. And I said that as well. Things are looking good. Thank you for your attention.